This work introduces an unusual coaxial helicopter, which requires only 2 actuators total to independently control all 6 degrees of freedom in flight. The swooping pitch and roll of a conventional quadrotor is a fundamental requirement of its underactuated dynamics. It must roll and pitch its body in order to point the thrust vector in different directions and maneuver through space. Surprisingly, we can emulate full actuation over both forces and moments using only 2 actuators. This aircraft can accurately track trajectories with lateral accelerations in excess of 1 meter per second squared while remaining perfectly vertical. A special flexible propeller allows us to control the tip path plane of a rotor simply by modulating the drive torque. The thrust vector remains perpendicular to the tip path plane and can be pointed in different directions. The rotor needs only one control input, the main drive motor. A passive teetering hinge allows the blades to flap up and down. Passive skewed lag pitch hinges kinematically couple lag motions excited by the drive motor into cyclic blade pitch changes. Those blade pitch changes aerodynamically drive a coherent flapping response, which we observe as a tilting of the tip path plane. The top and bottom rotors of a coaxial helicopter now give us control over 2 independent thrust vectors. We generate lateral forces by tilting both rotors together. This allows us to follow trajectories through space while remaining perfectly level. If we instead tilt the rotors in opposite directions, we generate rotational moments that can rotate the entire aircraft. By combining these techniques, the helicopter can even pitch the body back and forth while remaining in a stationary hover. Simultaneous control over position and orientation could allow micro vehicles to maintain steady camera views, use legible body language with human bystanders, or manipulate objects in the environment with both forces and torques.